Hi guys, I wanted to make a quick little video on binomial theorem. So the binomial theorem has several uses in mathematics, and not just in before and after calculus, in algebra, etc., discrete mathematics. However, what we're primarily going to be using it for is to expand polynomials, and that to do that, before we get into that, what we need to do is to be able to understand Pascal's triangle and what Pascal's triangle is. When you're using Pascal's triangle, you're using this because Pascal's triangle is what's going to determine the coefficient of each of the terms of the polynomials. So to make this, we just start off with a 1, and to the sides of that we have a 1, and again 1 and 1, and anything in between we're going to add together. So in other words, like 1 plus 1 is 2. So this third level we have 1, 2, 1, and then just repeat the process. 1's on the outside, 1, 1, and then 1 plus 2 is 3. 2 plus 1 is 3, and so on, and this will continue on infinitely, or for as many levels as we need. So we're going to leave it right there for a second. But the way this is going to work is, if your polynomial is, like, let's say to the 0 power, you're just going to use the 1. If it's to the first power, you're going to use this. You would just have 2 terms. 2, you're going to have these 3 terms. And this should look kind of familiar, when you have a trinomial and you have 3 terms. If you had, if this was to the third power, you would actually have 4 terms, etc. Let's do one more level. Number 1's on the outside. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then, of course, 1's on the outside. And that would be if this was to the 4th power. Okay. Now let's put this into action and see how this helps us. Okay, I'm going to do 2 examples for y'all. We're going to do two of the problems from example 8.6, binomial theorem. Number 1, in which case all we're doing is looking for the third term, and number 7, in which case we're going to expand that polynomial completely. I'm actually going to do number 7 first, because if we're looking for the third term, then we can just, get the third term. We can do it individually, but I wanted you to see this in action first. Okay, so first of all, because this is to the 4th power, the whole thing is to the 4th power, we're going to be using this 4th level here. So I know I'm going to end up with 5 terms here. You see here that you have 2 terms inside here, and this is how we're going to utilize this information. So I'm going to say that this is going to be equal to, we're going to have all of these over here. This is supposed to be an equal sign. Remember, you're going to have you're going to have 1, 4, 6, 4, and 1 for your coefficients. How do this here? This is because that was to the 4th power. The whole thing's to the 4th power. So it's going to be 1, 4, 6, 4, and 1 for the coefficients. So let's kind of set this up here. So I'm going to say, okay, the 1, and then I'm going to have 4, I'm going to have the 6, I'm going to have 4, and I'm going to have 1. Okay, now the thing is here, you have 2 terms in here. So each of these terms you're going to put here, to x to the 3rd power, 3y to the 4th, and then repeat the process. This is plus. This is going to be x cubed, 3y to the 4th. You're going to have this plus x cubed, 3y to the 4th, plus this is going to be x cubed times 3y to the 4th power, and then one more. Make that the plus 1 times x cubed times 3y to the 4th. Now anyway, this is how we're going to do this. Remember, this is to the 4th power. So the way this is going to work is, this first term I'm going to say is going to be to the 4th power, and the second one is going to be to the 0. These should always add up to whatever that exponent is for the whole thing. So that's going to be 4 and 0. So basically this first one is going to go from 4 down to 0, and the other one is 0 is going to go up to 4. So the next one, that's going to be 3 and 1. This first one I'm going to take all the way down to 0, and the second one I'm going to take all the way up to 4. So we can say 4, 3, here, let's do 2, 1, 0, then go backwards. The second one, let's start at 4, and then 3, and then 2, and 1, and then of course the 0. And this is all we're going to do, and then we're going to expand this. And we expand this by simplifying it. And by the way, if we were looking for a particular term, like let's say the third term, bam, you got it right there. Okay, but let's simplify this. Okay, simplifying this down, x to cube to the fourth, that's just going to be x to the 12th. Remember, use your laws of exponents. 3 times 4 is 12. And all this whole thing to the 0, so that's just the big 1. And then 4, and then x cubed to the third. 3 times 3 is 9, so that's x to the 9th. And then here, just this is to the first power, so I'm just going to bring that down. 3y to the 4th, plus 6 times x cubed squared. 2 times 3 is 6, so that's x to the 6th. 3y to the 4th squared. Each term is squared, so 3 squared is 9. Y to the 4th squared is just going to be y to the 8th. And then plus 4. X cubed to the first is just x cubed. 3, lost my place right there. It's going to be 4, and then x cubed to the third is x cubed. 3 cubed is 27, and then y to the 4th is 12. And then this is 1. X to the third to the 0, that's just the one big 1 there. 3 to the 4th is 81. And then y to the 4th is just y to the 6th, 81, y to the 16th. And simplifying this down, so we're just going to end up with x to the 12th plus 4 times 3 is 12. And then x to the 9, y to the 4th. 6 times 9 is 54, x to the 6th, y to the 8th. 4 times 27 is 108, x to the 3rd, y to the 12th. Plus 1 times 1 times 81, so that's just 81, y to the 16th. And here, this whole thing is expanded. Okay, so back to number 1, not number 1, back to, well, yeah, number 1. All we want is a third term here. For this, so in this case, since this whole thing is to the 4th power, we're still using this because we need to know what term we're talking about. We want the third term, so that means that we're going to use this third one, which is going to have a coefficient of 6. So the way we're going to do this, we're just going to say that this is going to be equal to 6 times, and then we're going to take the terms. The first term is 3y squared. The second one is just 1. Okay, remember this is going up to 4, so I'm going to say that this is 4. Sorry, not 4. This should be 4, 3, 2, so this is going to be 2. And the other one should be going backwards. This one's also going to be 2, because this one would have, the second one would be 0, 1, and then 2. And this is going to be 6 times 3 squared is 9. Y squared squared, 2 times 2 is 4. And then 1 squared is just 1, so this whole thing is just 1 here. Multiplying this together, the third term here is just 54, y to the 4th power. Okay, so here, this is what you do for individual terms. Here, if you're going to expand the entire thing, like on number 7. If you have any questions, make sure you shoot me an email or join one of the Zoom sessions. Talk to you later. Bye.